Hello students, welcome to Educate. Today we are going to study next chapter of class 11th physics, that is work, energy and power. So you have basic idea about work, energy and power. Just we are going to recall the concepts and after that we will go in detail. So if you remember, work is equal to force into displacement. We can see different situations. What happens? Suppose this is an object. Force is applied in this direction and displacement is also in the same direction. Then W is equal to F into S. No doubt. But suppose force is acting at certain angle. Force is in this direction, displacement is in this direction, or you can just take like this. Force is acting in this direction and displacement is in this direction, and angle between the two is theta. In that case, what will be the work done? So in such a case, when force and displacement are at certain angle, in that case we write the formula Fs cos theta, and then accordingly we will put the value of theta starting from 0 to 180 degree. So here different situations if we consider. So suppose theta equal to 0 degree, then what happens? This will become 1. If theta equal to 90 degree, then what happens? This term will become 0. And if theta equal to 180 degree, then what will happen? Then here cos 180 degree will give -1, so W will be negative Fs. So negative work will be done. We will see different cases when positive work, when negative work is done. So here we are just studying the introductory point. Now this is basic concept of work done. Then comes energy. Different forms of energy you have studied, like when you talk about kinetic energy. So by virtue of motion, that is given by 1 by 2 mv square. And if you say potential energy, so this is due to position or shape, that is mgh. And we have also studied basic laws like energy conservation, that total energy remains conserved. So that concept we will study here also in detail. And one more concept is there, work energy theorem. So it states that work done will be difference in energy. Like suppose a body is moving with velocity u and now it changes its velocity to v. In that case, what work will be done? So here we can say 1 by 2 mv square minus 1 by 2 mu square will give work done. So these are some basic concepts. Moreover, suppose we want to define power. So we have studied earlier that either we write here energy or work. And if we divide by time, what we get, that is power, and unit of power is joule upon second, that is watt. Now the same thing we are going to study here in detail. Here the first concept given is scalar product. So we have earlier studied about vector product and scalar product. So in case of scalar product, what happens? Suppose we want to find out work. So work is a scalar product of force and displacement. F dot S. Suppose force is given in terms of vectors, say 2i cap plus 3j cap plus k cap Newton. And displacement is given, say I cap minus 2j cap plus 3k cap meter. And we want to find out the work. In that case, what do? We just find F dot S. which is W, which is a scalar quantity. And then if you remember, I dot I gives 1, but I dot j or I dot k gives 0. So only we have to multiply the coefficients of II, JJ and KK. So here we will get 2 into 1 minus 3 into 2 plus 3 into 1 joule. We can evaluate. So here the concept of scalar product is used for this purpose. Let's see what is given in the textbook. So here the same thing is given: a dot b equal to ab cos theta, etc. A dot b equal to b dot a. Here if you multiply a dot, then inside if there are two vectors, then separate multiplication means distributive property will be there. Separate dot products can be taken, and if there is a scalar number, so you can take it outside and then you can do. And as I told you, I dot I, j dot j, k dot k equal to 1, and I dot j equal to j dot k is 0. Now here, suppose you want to find out the projection of one vector over another vector. So suppose this is vector A and this is vector B. So projection of vector A means it's a component along second vector. This angle is theta. So component of A along B will be A cos theta. Similarly, projection of B over A, so it will be B cos theta. Now suppose you want to evaluate its numerical value. Suppose you are given a question. Suppose you have a vector A is say 2i plus j minus 2k, and there is another vector, say vector B equal to I cap minus j cap plus 3k cap, and you have to find out cap. Here, suppose you have to find out projection of vector A on vector B. So what is necessary here? You have to take a unit vector in the direction of given vector. So you have to find out projection of this vector in this direction. So for this purpose you need unit vector B cap. So B cap will be vector B divided by modulus B. So projection of A, you can say projection of vector A over B over vector B is equal to A vector dot B cap. But B cap means vector B upon modulus B. So vector A dot vector B divided by modulus of vector B. And then you can easily evaluate. First you find out A dot B. As I told you that coefficients of I, J, K, K will get multiplied. Rest will give result 0. So we can ignore. And then modulus B you can find by putting like this: B equal to square root of coefficient square 1 square plus 1 square plus 3 square, that is 9, and it will be root 11. So this is how you can find the projection of vector A over vector B. And its reverse is also possible. Suppose you want to find out projection of vector B over vector A. So for this you have to take the component of B over A. So direction here A cap is needed for this purpose, and here you write B vector, and then you will write vector B dot vector A divided by modulus A, and you can easily get the value. Let's see here in textbook one question is given. So let's see the question. What does it say? So it says something. You are given, find the angle between force F and F unit and displacement D unit. Also find the projection of F and D. Projection, how to find? I told you. F on D means D cap you will need, and then you will write F dot D cap, and then you can evaluate. But here, if you want to find out what is the angle between these two, so if you remember, we have studied about dot product of two vectors. If you are given vector A and vector B, so we can use A dot B divided by modulus A modulus B. This gives cos theta. So from here, theta equal to cos inverse this value. The same thing can be done here also. So whatever they have done, that does not matter. You can directly do, like you can write cos theta equal to dot product of these two. So 3 into 5, and then 4 into 4, then 5 into 3 divided by square root of 9 plus 16 plus 25 times, from here 25 plus 16 plus 9. So here it will become 25, 50. So root 50, it will become 50. So 15 plus 16 minus 15 divided by 50, that is 16 by 50. So 16 by 50, which is 0.32. So this is cos theta. Now if you use calculator to evaluate cos inverse 0.32, you will get certain value. So this is our question. I think you have understood. Now we are going to take next question. Here, notion of work and kinetic energy, the work energy theorem. As I told you that work is equal to change in kinetic energy. Suppose initially body is moving with velocity u, and after some time it attains velocity v, then change in k will be half mv square minus half mu square. So work done can be calculated. Here there is one question based on it, but before that let's take some simple examples. Suppose you have an object whose mass is say 1 kg and it is moving with u equal to say 5 meter per second, and then its velocity increases to 10 meter per second, and you have to evaluate work done. So it is simple. 1 by 2, m is 1 into v square, that is 10 square, minus 1 by 2 into 1 into 5 square. You simplify and then write in terms of joule. So you have understood how to use work energy theorem. Now here there is one question. Let's read it and try to analyze what is given here. It is well known that a raindrop falls under the influence of downward gravitational force and the opposing resistive force. So raindrop is falling, there will be influence of gravity, but as it falls, there will be air resistance which will oppose its motion. Here it is given that air resistance is proportional to the speed of the drop. It means speed of drop will go on increasing, so air resistance will also go on increasing. Consider a drop of mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. What is the work done by the gravitational force? What is the work done by unknown resistive force? So let's evaluate it. Here, change in kinetic energy we can find. Initially, we assume that raindrop was at rest, so change in Ke, delta Ke is half mv square. So mass is given as 1 gram. 1 gram can be written as 1 into 10 to the power minus 3 kg, and velocity acquired is 50 meter per second square, so 50 square, sorry, 50 meter per second, so 50 square. We evaluate it, which it will come out to be 1.25 into 10 to the power nothing, 1.25 joule only. So we have got change in kinetic energy. Now, work done by the gravitational force, so W gravitation is equal to mgh. So we can put the values. So m is given as 10 power minus 3 kg, g we can take as 10, and height fallen is 1 kilometer, that is 1000 meter. So this will give just 10 joule. Now, work energy theorem says that change in kinetic energy delta Ke must be equal to work done. Here work is done by resistive force as well as work is done by gravitational force. So we can say that this much 1.25 joule energy is equal to 10 joule plus work done by resistive force. Say we denote it as WR. So we can calculate work done by resistive force, which comes out to be negative 8.75 joule. So I think you have understood. It is simple. First we have calculated change in kinetic energy, then we have calculated work done by gravity, that is mgh, and then work done by resistive force can be calculated by using work energy theorem. So question is good. Now let's see next thing. Here work done is explained as I told you that this is object which is moving in this direction. Suppose it has covered a distance d and force is applied at certain angle. In that case, what will be work done? So work done in such a case will be Fd cos theta, where theta is the angle between the direction of motion and the direction of applied force. Now, on the basis of this knowledge, we can say that work can be positive, negative, or zero. So as far as theta equal to, here you have seen that W is equal to Fd cos theta. As far as theta is less than 90 degree, theta is acute, work will be positive. If you remember, in case of cos theta, if you plot the graph, what do you get? Graph is like this. This is 0 degree, 0, this is 90, and after 90, it becomes negative. Here it is positive, here it is negative. Now, situation is shown here below 90 degree. Till here, graph is positive, it means this term will remain positive, so work done will be positive. At 90 degree, cos theta becomes 0, so work will become 0, and when theta increases beyond 90, so here it becomes negative, so work done will be negative. So all situations are written here, you can read it. So same thing is given here. I'm not going to read, you will understand it. Now there is one question here. A cyclist comes to a skidding stop in 10 meters. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. Here, theta will be 180 degree because force is opposing the motion. So work done, if you want to calculate, in that case you will say that it will be resistive force. So if you apply, sorry, it's not F, So W equal to FD cos theta, put theta equal to 180. So cos 180 is -1, so negative F into D, and put the values. So force is 200 and distance moved is given as 10 meter, so this much. Here there is one important point. The lesson of this example 5.3 is that though the force on a body A exerted by the body B is always equal and opposite to that on B by A, Newton's third law, the work done on A by B is not necessarily equal and opposite to the work done on B by A. You have to keep this statement in mind. This is for competition purpose. Now we are going to study about kinetic energy. I told you about kinetic energy, that kinetic energy is given by half mv square. On the basis of kinetic energy formula, there is one question. Let's read the question and try to solve it. In a ballistic demonstration, a police officer fires a bullet of mass 50 gram with a speed of 200 meter per second on soft plywood of thickness 2 centimeter. The bullet emerges with only 10% of its kinetic energy. What is the emergent speed of the bullet? Here initial velocity means if you calculate kinetic energy initially, so 1 by 2, and mass is given 50 gram, 50 into 10 to the power minus 3 times velocity square. So velocity is given as 200, so 200 square joule. Now the bullet emerges only 10% of its initial kinetic energy. So we can evaluate it 1 by 2, 50 into 10 power minus 3 into 200 into 200. If you evaluate it, what do you get? So here 10 power minus 3 and here 10 power 3, you can cancel 2, 3. This got cancelled. Here 40 and this. So is it correct? So what do we get from here? This is 40, 50. This is 1000. In our question, it's given. Here there is variation. Why? So that we are going to check whether this is 1000 joule. Yes, it is 1000 joule. That is correct. Now, only 10% of this kinetic energy is possessed when the object comes out. So 10% of kinetic energy, so 100 joule. So with 100 joule, the body comes out. So here we have to find out what is its velocity. Situation is like this. Suppose this is a block. At the entry point, energy is say Ke, and at exit point, here energy is Ke by 10. Correct? So this is say Ke dash. Here Ke is 1000 joule and here it will be Ke dash is 100 joule. Same formula will apply at this point also, half mv square, but there will be new velocity. So you can say 100 equal to half m. Suppose this time we write v1 square, or vf square can also be written. So this will become 200 divided by mass 50 into 10 to the power minus 3 equals V1 square. So we can take square root. V1 will be equal to, from here this will come to 200 into 10 to the power 3 divided by 50, and this 50 with the square root, this 50 will cancel it 4 times. So 4 followed by, it will become 4000, and then 4000 if we take out square root, so this will come out to be V final or V1 as we have denoted it is 63.2 meter per second. Now question is, by how much percent speed is reduced? What was initial speed and what is final speed? So what you have seen here, initial speed was 200, V initial was 200 meter per second, and final speed is 63.2 meter per second. What is percentage decrease? So percentage decrease can be found by using formula decrease into 100 divided by original. So what is decrease? 200 minus 63.2 into 100 divided by 200. If we evaluate it, it will come out to be around 68%. So the same thing is given here. The speed is reduced by approximately 68%. Now we are going to see, if there is a variable force, then what will be work done as against the constant force that we have used here as F d cos theta equal to work done. So here force was constant. Now suppose force is variable, it can vary like this. Suppose force is going like this, or force varies like this. So we can use integration in that case. So work done can be written as limits from where to where. Suppose this is point x1, this is point x2. So we can integrate it. So we write here x1 and x2 f dx, and then we can put the value of f, and then we integrate. I'm giving you general example, then we will see what example they have given. Suppose you are given, say, f equal to 2x plus x cube. Here we can write in terms of x I cap j cap. So I have just taken this. I have assumed that force is function of x in Newton, and x is, say, 2 meter, x1 is 2 meter, x2 equal to, say, 3 meter, and you have to find out what is work done. So formula work done equal to 2 to 3 and 2x plus x cube dx. Now you can integrate it. So twice of this will become x square by 2 plus x power 4 by 4, and then limits 2 to 3. Sorry, 2 to 3. So here 2 will cancel out, and in place of this x square, you can write 3 square, then you write 2 square. So first one is evaluated. Similarly, keep 1 by 4 outside, and then 3 power 4 minus 2 power 4 joule. You just evaluate, you will get the answer. So this is how work done by variable force can be evaluated. Now the same thing is shown here graphically. We can take any 2 points. Suppose this is here the points are xi and this is xf. So work done will be xi and xf. They will be the upper and lower limit and upper limit, and then fx dx, where f is function of x. Now we can see here there is one question. This is also same thing. Here there is a question based on the same concept. A woman pushes a trunk on a railway platform which has a rough surface. She applies a force of 100 Newton over a distance of 10 meter. Thereafter, she gets progressively tired and her applied force reduces linearly with the distance to 50 Newton. Situation is shown up to point C. Here, till 10 meter, force is constant. But after that, it starts reducing linearly, and till 20 meter, it becomes 50 Newton. So the total distance through which the trunk has been moved is 20 meter, as it is clear from here, 0 to 10 meter, then 10 to 20 meter. Plot the force applied by the woman and the frictional force. So in question, this graph was not given. So you can easily plot the graph. Here this is force, this is distance axis, and till 10 meter it was constant. That is why here this is 50 Newton, 100 Newton, because two values are involved. That is why those major values are given here. But keep in mind, here minus 50 Newton frictional force will also act. That because applied force was 100 Newton in the beginning, but it reduces to 50 Newton. It means there is force of friction of 50 Newton. So here work done by the lady is to be calculated, and for that you have to consider figure A up to here, I, E, C, B, and work done by frictional force will be just this O, I, H, G. This is rectangle, it will be negative, so it can be easily calculated. So to find the area here, length into breadth can be applied for this, and then you can apply the area of trapezium. Here these are two parallel sides, CD and EF, and this will be the perpendicular distance. And you remember that area of trapezium is given by 1 by 2 sum of parallel sides A plus B. Suppose we write the parallel side here, CD, suppose this is A, this is B, and then this is height into H. So area of this rectangle plus area of this trapezium will give total work done by the lady, and work done by opposing force, that is frictional force, will be area of this rectangle starting from 0 to 20 meter length and this 50 meter breadth, and it will be negative. The same thing is explained here also. Next point is work energy theorem for a variable force. So let's do that also. So kinetic energy, you know, K is half mv square, and we know change, we want to find out change in kinetic energy, because if you remember, change in kinetic energy gives the work done. So let's find out, let's denote it as K, and we find dk upon dt. So dk upon dt means d upon dt of kinetic energy 1 by 2 mv square. Here mass is constant and v is variable, velocity is variable. So if we differentiate v, so it will give 2v dt. Why? Because if you remember, d upon dx of x power n gives nxn minus 1, but d upon dt of x power n will give nxn minus 1 into dx upon dt. The same thing will happen here. Since it is dt and it is v, so we have to multiply it by dv upon dt. So it will become 1 by 2 m into 2v multiplied by dv upon dt. So 2 will cancel out, and even we can cancel dt from both sides. So mv dv will be left in RHS and dk will be left in LHS. So what we do? So our next step will be dk is equal to here mv dv. So dv upon dt is velocity divided by time, is acceleration. So we can say MAV, and MA is force. So force, and here dt, so a force upon. So we can do one thing here, slight change. Up to here it is correct, nothing is wrong. So we have got dk upon dt is equal to mv dv upon dt. And if you remember, m into dv upon dt, here dv upon dt is acceleration. So ma is force. So this is F into V, no problem. And velocity can also be written as dx upon dt, displacement upon time. So again, dk upon dt will become F times dx upon dt, and dt can be cancelled. So dk is equal to F dx, and if we integrate it, then on integration, suppose we put the limits of kinetic energy as kinetic energy initial and kinetic energy final, and for this we put the limits that force is applied from this point xi to xf. So here we write xi and xf and f dx. So this will be change in kinetic energy. Here dk is there, so this will give change in kinetic energy. So k final minus k initial, which is delta k, equal to integration this. So we can write it like integration x1 to x2 and f dx. So this will give work done. So change in kinetic energy equal to work done. So this proves the work energy theorem for variable force. Now here there is one question based on variable force. Let's see what is the question. Question says a block of mass 1 kg moving on a horizontal surface with a speed of Vi as 2 meter per second enters a rough patch ranging from x equal to 0.10 to x equal to 2.01 meter. The retarding force Fr on the block in this range is inversely proportional to x over this range. So here retarding force is given as minus k upon x, where k equal to 0.5, we can place here. For 0.1 to x, means this is range 0.1 is less than x is less than 2.01 meter, and after that it will be 0. What is the final kinetic energy and the speed Vf of the block as it crosses this patch? So what is the situation? The body is initially moving with certain velocity that is given 2 meter per second square. So we can find its initial kinetic energy, say Ke initial, or K initial we can denote. So will be half mv square, and mass is given half, and then what is mass? So in this case, question, body of mass, how much? It is 1 kg. So K initial equal to half into 1 into v square, velocity is 2 square, that is 2 joule. Now this energy will be reduced by frictional force and a retarding force that is given by Fr equal to minus K upon X, or minus K is 0.5 divided by X. Now this is variable force. We can calculate the work done in this range. So let's evaluate it. So final kinetic energy will be equal to K final will be equal to K initial plus, we calculate, we use this. So integration K initial we have evaluated as 2 joule. Now here the range starts from 0.1 to 2.01. So we put the limits here. Lower limit is 0.1 and upper limit is 2.01, and force is minus 0.5 upon x and dx. Here we have to apply formula integration dx upon x equal to log base ex, which is also written as ln x. So we will get K final equal to K initial, that can be written as 2 minus 0.5 this, and ln x limits 0.1 to 2.01. So property of log, if you remember, log m minus log n gives a log m upon n. So same thing will happen here. If we put the limits, then what do we get? So we will get K final equal to 2 minus 0.5 into ln and 2.01, here we put bracket, minus ln 0.1, and then apply that property log m minus log m upon n. So it will become kf equal to 2 minus 0.5 ln 2.01 divided by 0.1. This is 20.1. So kf equal to 2 minus 0.5 minus ln 20.1. Now we have to use log table for this. So log table is generally based on natural log. So relation is log base e x is 2.303 log 10 x, log x base 10, and we can get the value of log x base 10. So same thing can be done over here. We can convert it into log base 10 and then we can use log table to get the answer, or directly we can use calculator. So that has both functions. So 2 minus 0.5 into 2.303 into log, here ln was log base e, here log base 10. Either you write or don't write 10, that does not matter. It is understood that this is based on, so this is log 20.1. If you see log table and then you write its value, so after evaluation of all three, it will be around 1.5. So this gives 0.5 joule. So you have got final kinetic energy as 0.5 joule. Now, suppose you want to find out final velocity, because question is what is the final kinetic energy? So that we have got, and the speed with which it comes out from the patch. So if final kinetic energy this much, so final velocity can be found. So kinetic energy is half mv square. So 0.5 equal to 1 by 2, mass is 1 into v square. So this will become 1. So if you multiply, so you will get a v square equal to 1 or v equal to 1 meter per second. So this is the answer. I think you have understood. Thank you. Team Educate.